Hello, this is Nitin Dahad with EE Times. Welcome to this latest edition of Silicon Grapevine, brought to you by Synaptics. On this episode, which is entitled Sense and Sensibility, we're going to talk about how multimodal inputs help robotics get a grip. And to discuss that, I have Satish Ganeshan of Synaptics. Hello, Satish.
Hey, Nathan, good to see you as always.
And Sam Tober, also with Synaptics. Hello, Sam.
Hi, Nitin. Good to see you.
Okay. Well, good. So before we get into the discussion, I think one of the things we're all hearing about is physical AI, humanoid robotics. But in this podcast, we're going to discuss how those humanoid robotics can enable I think what your CEO Rahul Patel said in a blog that you've published on your website, adapt to the real world in unpredictable environments. And
Right.
I think, and that's kind of requiring a lot of multimodal sensing. And we're going to talk a little bit about how Synaptics experience in capacitive touch, etc., will enable humanoids and robots that sense of touch. And we'll talk about the various aspects of that. But before we do that, let's just go into a little bit of background. So, Satish, just explain a little bit about you, your role, and how you got into doing this at Synaptics.
Sounds good. Hey, Nathan, thank you for hosting us. You run a great podcast, and we're happy to be a part of it. I'm Satish Ganesan, the SVP and GM of the Edge Interface and Sensing business at Synaptics. I also double up as the Chief Strategy Officer. And, I have a computer engineering background, electrical and electronics background. And at some day, I actually always imagine that'll be put to best use. And I think off late, as a part of running this business, we focus on all of the sensing modalities we are talking about for this podcast. And the exciting part is we transformed Synaptics over the last 6 years from going from a mobile only, PC only company to more diversified edge AI and physical AI company. And as a part of that, and while introducing all of these elements in sensing, along with processing and connectivity, robotics, and in general, physical AI has brought all of these things together in a single device like no other device from before. So I'm pretty excited about that and all of the learnings and how we put that in perspective, and glad to share it with you today.
Well, I think one of the things, I think just probably when you said what you said at the beginning, when you studied in the beginning, I think, back in BITS Pilani,
That's right.
I think it was very much, there were the whole thing around, it was all around automation in factories. But even then, it was very basic and rudimentary. Did you ever imagine that we'd be able to have robots, moving things? And that's what we're going to talk about.
That's great, isn't it? I mean, never, right? It was more rudimentary, like you said, and the industry has come a long way since then, right? Since the late '90s, early 2000s to now, what we wanted to do in semiconductors has always kept defying Moore's law, and now here we are trying to basically figure out how to make a robot sense like a human. And it's so exciting because one of the things that we can do and we've always done in this industry is, again, we talk about Moore's law, we've expanded the capacity. So now we are basically expanding capacity by doing a lot of compute. We're putting compute in the cloud, we're putting compute here, and the brain, interestingly, is our best computer here, right? But our body operates is in what's called a neuromorphic computer. So you have parallel processing that's going on. So not everything goes to the brain that sees video and things like that, but a lot of sensing happens in the body. There's about 10,000 sensors in your hand or something like that basically detects spikes of sensing and understands what's going on. So putting all that in perspective and getting to this point and trying to make a robot, a non-living organism, reproduce what a human does, and take it across humanoids, across cobots, across grippers, and so on. Pretty exciting times.
Well, we're going to get into some of those examples later, but let's just get a quick introduction. Sam Toba, tell us your role and how you got into all of this.
Nice to meet you. I'm Sam Toba, Senior Director of Product Marketing, as I mentioned. My background is with power management. I've been in roles managing PMIX, audio, in touch. And what's interesting about this background is that robotics is all about multidisciplinary, understanding all the different types of sensors and types of silicon that you can implement. And as Satish mentioned, this hand is an incredible piece of engineering. It has so many different kinds of sensors and requires so many different types of silicon. And yeah, we're very, very excited to implement these in this growing industry.
And I think you spent several years at Maxim on those
That's right.
power management ICs. Now that those technologies have moved on so in such a big way that to enable that sort of capability in humanoid robotics and grippers and things like that. What do you see as the biggest change there or transition?
In the humanoids world, or
Yeah,
the
or just in that power management.
power management world, I mean, it's become. I mean, when I first started in power management, it was very, very simple, converting voltages. But as things progressed, there's a lot more intelligence added, and you see that in all of the silicon chips, and even at Synaptics, we use a lot of actual compute in our touch sensors, and that's actually become very, very useful in our robotic sensing because, again, as Satish mentioned, there's a lot of compute happening in the hand itself, and we have
Yeah,
to filter out the noise, we have to condition the signals, we have to report meaningful events to the host because otherwise the brain will get inundated with so much data. So there's a lot going on, and I think we're experiencing a confluence of all these things happening. Very, very exciting again.
very good. Well, I'm going to just ask Satish to maybe set the scene a little bit. What do we expect of humanoid robotics, and what are the things? Yeah, what's the problem statement, and what are we trying to do?
Yeah, I mean, just think about it, right? When I'll just use my phone here. So, I'm picking up my phone and I'm talking to you. I'm trying to do a math problem, or trying to help my daughter do some math or whatever it is, right? So, and if it gets pretty complex and advanced calculus, I have to go back and look at what exactly I learned in the past. The compute in my brain, right, that's the one that we struggle with. At after some point, we need help. We need
Mm,
calculators. We need a computer. We need all of those things to do it. We have a
right.
lot of compute, right, to go ahead and help us to do that. So we can offload it to a bunch of processes in the data center, and we have kind of infinite compute being built up. But
Mm,
what I'm doing right now here is I didn't even talk about it. In the background, I'm basically holding my phone. I'm fiddling with something and doing all of those pieces. You're barely being taxed in your brain doing all of those functions. The humanoid, and when we want to get into this whole robotics world, this problem, and I'm gripping my phone as well very easily, this problem is the toughest problem to actually go solve,
yeah.
because basically being able to grip something without letting it slip and
Mm,
understanding the what kind of object is it solid, is it glass, is it kind of like a spongy material, whatever it is it eggs, it is cake. Being able to identify that uses such level of sensors and brain power of a robot compared to what humans do. Now the question is, if we want humanoids to behave as close to humans as possible, or robots to behave as close to humans as possible, this needs to change, and hence is the toughest problem in robotics and is the one that could slow the whole the market down. So what we are trying to do here is play our part in solving this particular problem. And we're talking about the hand today, but it's the problem of basically sensing and computing, kind of in a neuromorphic way, so that we can simplify that issue, so that all the tax is not on the brain. It happens a little bit at the edge itself, right? Within a robot, if you will. So I think that's what the problem statement is, and the question is, how do we go about solving that? How do we go about sensing it?
mm.
What kind of sensors do we have to use? We will talk about capacitive sensors and other modalities that we do. And then how do you aggregate all the data I just computed in the edge itself and not basically bring it back? I think that's the problem statement. That's the tough thing in the market, which is why we are excited about it, because when there are challenges is when innovation is required. And I think we stand at the forefront of that right now.
Just to put those in different words, and I know you stated that problem statement, but I guess it's about enabling that robotic gripper or hand to feel and sense, so that it can decide whether it's say, for example, in a retail warehouse, and it needs to grip a tomato or tomato very lightly, or whether it's a glass in a restaurant or in a factory where it's handling something fragile. So I think those are all these things where you're trying to put lots of different sensing modalities in to then process without having to send it back to the brain. Is that right?
That's correct. That's correct. And on top of that, sometimes you can see stuff. So if the
Okay.
robot has eyes too. So there's a way in which these have to communicate. But sometimes you cannot see stuff if you're picking something from behind, or you're doing something where you cannot see stuff in a manufacturing plant if you have to work lights out, which is one of the advantages of doing a robotic line, is you don't want to keep the lights on because you want
Yeah.
to reduce the amount of power. Then what do you do when you can't see stuff? Then you have to sense stuff a little bit more. And sensing involves a bunch of things, right? So when you try to again pick up an object, when you come close to an object, you're kind of sensing that there's an object. And then when you pick up an object, there's basically the soft grip that you have to identify what the object is. And then you have a firm grip to basically hold the object. And sometimes you want to squeeze the object, which is the harder grip. Each one, depending on the material that you have, the sensing, the skin that you have, each one represents a different sensing modality, a different
Yeah.
level
Yeah.
of electrical spike that's sent. And so the problem statement is exactly at the highest level. All of this happens just in the background in a human body, and so you just do this. Now how can you make a humanoid do that? Because that's kind of what we're talking about, a dark factory that you have to make this work. A
Mm.
humanoid at home where it can sometimes see stuff, it can sometimes not see stuff, whether the materials and so on, and depending on the material, it changes its grip to make sure things don't slip, right? And as
Yeah.
long as
Yeah.
things don't slip, they don't fall, they don't break. And I think that's the problem statement.
Sam, maybe we'll come to you on the specific technologies like capacitive sensing. Tell us a little bit about all the different ways in which
Sure.
this
Yeah, yeah,
helps
yeah.
address that problem
Yeah.
statement.
So yeah, building on what Satish meant, just gripping alone is a pretty complex task, right? You have to sense it with your 5 fingers, or however many fingers your gripper has. Let's imagine it's 5 fingers. 5 different fingers with each of these tips need to sense the location of the object that it's being gripped. Capacitive sensor is actually pretty good at detecting the 2D area of where it's being gripped. The reason it's
Okay.
important to detect where you're gripping it is, as you grip, you want to make sure it doesn't fall. You want to make sure the friction levels are the same. In other words, the force levels are the same. You can detect that that's changing with capacitive force sensing. But in addition to that, we want to make sure we detect before it slips, because communicating all of that information to your brain and back, that's going to take many, many milliseconds. So
Mm.
that's where the multimodality comes in. We have to detect the friction, we have to detect the vibration, all of those, and calculate it locally. And remember, you have 5 fingers. All of these have to talk to each other, so to speak. So all that data needs to get aggregated, calculated, processed, event detected. And then if there is a need to tighten the grip, that needs to be communicated, if possible, locally. Because if otherwise, remember, it's going all the way back and coming
Yeah.
back,
Yeah.
it's going to be too late. And the difference
Mm.
right now with robotics is that robotics humanoids are being placed into unstructured environments. Robots previously were in factory lines doing predictable things
Exactly.
over and over and over. So that's the thing
Mm.
that makes it different now. And that's the thing why you need to have more than just vision to plan your action and act locally. So there's a lot going on with capacitive, adding modalities. In addition to that, we're going to have to start adding temperature sensing. So we're, as a company, building up on those different sensing modalities on the fingers.
I mean, just to try and understand, in those the whatever it is, the gripper, the hand. I'm guessing there's going to be a lot of sensors, or are there going to be sensors which are multifaceted?
There are many, many
You have
sensors, yes.
okay,
So yeah, there's touch sensors, there are vibration sensors, there are motion sensors, there are angle sensors, temperature sensors.
okay.
All of these need to communicate with each other. And the other pain point that's becoming very, very evident with these robotics makers is the
That's a good pun,
lines.
by the way. Pain point.
Yeah,
Pain
pain
point.
point, not intended. I get that's another receptor that needs to be added. None of these robotics have pain receptors now. They're all
Yeah.
motion, position, shape. But communicating that on these lines, that's becoming a pretty big problem because there's so many sensors. So all of those communication lines also need to be aggregated. So there's a lot going on in these tiny, tiny fingers.
And I think we're focused on the sensing, but I think it's a combination. And I think as you've written in the your own blog, the from your CEO, the key to intelligent systems is a combination of the multimodal sensing, contextual awareness,
Yes,
and real time inference. So I guess
exactly.
there's a lot of elements involved in this system, which is
Right.
sitting in these grippers. Is that right?
Exactly,
I mean, who wants
exactly.
to take that?
Yeah, yeah. And I mean, like I said, because we are no longer dealing with structured, predictive environments, a lot of it has to happen very, very locally. So judgments need to be made locally. Is it going to slip? Not going to slip? Is it hard? Can I grip harder or softer? All of those actions need to be decided locally.
Yeah, and I'll add to that, Nitin, a
Mm,
little bit. And what we're talking about here is, like I said, I run the edge interface and sensing business, and we have the
yeah,
compute and connectivity business as well. And so part of the thing that Sam's talking about is you have all of these sensors, and we do capacitive sensing, which is the primary modality. It's actually helping a lot of problems here. But we're going
mm,
to add all of the secondary modalities, and they all have to be routed through, right, using flex cables or whatever it is like that. And then you need the decisions to be made almost instantaneously, which means the latency has to be extremely low because
yeah,
you have to actually make the decision. And so typically what we are doing here is you understand the context from all of these sensors. And we are used to working with multiple sensors, interestingly in our PC business, because we use the touchpads, we provide the capacitive and force touch there, but we have other haptics and all of those things coming into our processing solutions and so on. But here you have to add a little bit of intelligence on top and interpret that data and actually make a decision. And that's where our AI native processors or MCUs that we are building as a separate line, that comes in where all of those things put together come into this processing solution here locally to kind of mimic the neuromorphic function I was talking about. So
right,
think
correct,
of it as,
yes.
hey, that's the spinal cord. It's not really the spinal cord, but hey, that's kind of where the decision is being made. And you're trying to make the decision in the hand or in the foot or in your
Mm,
body somewhere. That compute needs to happen locally, primarily driven by, hey, all these inputs cannot be routed through all the way and back because there's so many signals. And you have to make the decision so quickly. So this distributed neuromorphic computing kind of solution can be done by basically putting processors, understanding the context, understanding the sensing, and making the decision right at the edge. And that's kind of why we're excited, because we have all of those pieces to put all the solutions together.
Now, I've seen this in various trade shows that you've exhibited at over the last year, and your own Synaptics Tech Day. Give us some real world examples of what you're already doing, so that our sort of viewers, readers can understand the extent of what's already available and what the capabilities are now, and maybe just a little bit of a vision as to what the roadmaps might look like over the next 12,
Yeah,
12 to
I can
24
talk about
months.
I can talk
Yeah,
about the fingers. I mean, we're already able to sense at the fingertip at millimeter type of a resolution, and in addition to that, we are going to add vibration sensing, and that's going to detect what's called incipient slip. Because what after you start detecting the motion of the slip, it's too late. So there are ways of detecting that slip is about to begin. So those can be done with vibration sensors. We'll feed those into our touch chip and pipe it to the host. In other words, the hand aggregator. And we are planning on adding additional sensing modalities: temperature, motion, angle. All of these things can be added together and piped to our aggregator to make better decisions. So these are happening over the next position already we have in place. We will layer on the vibration sensor in a couple months after that. This industry is moving very, very rapidly, so we're going to very rapidly iterate with our customers as well.
and I mean, could Satish maybe just
Yeah.
talk about some of those types of applications we're seeing already that you're
Yeah.
seeing deployed.
Yeah.
I,
Fundamentally,
I know we know the technologies here, but I think
yeah,
just
yeah.
trying
I
to
mean,
figure out. Yeah,
fundamentally, and we talked about it in our last earnings script. The market that we're seeing the most traction is, and the market where most of the VC money is flowing in as well, apart from the big names that are doing this stuff, is in the humanoid space. So what we are
okay,
basically seeing, the first movers in terms of trying to understand and create solutions in the market is all of these humanoid players. So we are actually right now with in more than 35 to 40 customers. We are deeply engaged with all of
wow,
these customers, and these customers fall into two categories. One is the guys who are heavily funded, who see this problem, who are trying to solve this problem, understand what Synaptics can bring to the table. We are deployed as chip solutions there, and we're working together with them to understand all of this data in the context of the problems that they're trying to solve, and they themselves are understanding what context they're going to put their humanoids through. So it's the data is basically increasing, and we have a few design wins. We have about a couple of design wins there in some of the key marquee names of in the market. So and you can guess who that is, but that's kind of the names that we're working with in terms of the humanoids and robotics. And then there's a bunch of what I'd call I wouldn't call them tier two because they're very well funded, but I'd call them people who have a lot of mechanical engineers, how to put the robot together and all of those pieces. But on top of that, you have to basically get the modalities working. Apart, the humanoid has so many components, right? So the tactile sensing, they want Synaptics to build, kind of the module, kind of the sensor, kind of the skin, figure out the whole thing and give them a solution. So while we're working with this entire market, we're trying to figure out the entire solution, build it for the market. We believe the first solutions that we come out with and solve problems will be for the humanoid markets. However, there's an entire market called the gripper market that's available that also is now reaching out to us for tactile sensing solutions. So while the humanoids are expected to grow at this curve, and we'll see how that goes, right? Because there's a lot of steps that need to happen. We think the innovation cycle right now is what's happening in the humanoids, but the deployment cycle, once we cross the innovation cycle, might happen faster in the gripper market and the industrial market a little bit more, and the humanoids will catch up as they get deployed and the business models get identified for those who are building it, right? So I think that's how we are seeing it going, but we're excited because there's engagements are like crazy, and the good part of this market is customers call us. We get calls from all these folks to say, hey, can you help us build this thing because you guys are the experts. So that's kind of how I see the market playing out.
But I think there's always been like in this industry, a spearhead market, and then a lot of transfer of that technology to lots of different other
Absolutely.
applications and markets, which is kind of what you're implying here.
That's right. And sometimes what happens is it's like the consumer and enterprise market, if you will, right? So there's consumer market will just do the innovation, things will move fast, but then the enterprise market will be the stable one that keeps providing all
Yeah,
these solutions.
yeah.
And you'll find the same thing, humanoids, whether it's consumer humanoids or industrial bots, right? So there's going to be a combination of those two, and one of those will pick up. Now, I'm not predicting which one is going to go ahead faster. I'm not in the business of predicting, but the good part is I think there's transferable technology here, and it's going to go to a variety of markets, and we are pretty excited about it.
I think this year, 2026, or maybe last year, I saw a video of a startup in the Bay Area, very slick video on on this humanoid robot in the kitchen and in where different environments, making you an espresso, pouring you a glass of whatever you might be drinking,
Yeah,
uh, and it was quite interesting that that's the vision is being portrayed, but actually that consumer market may be a long way away,
that's
but
right.
I think it'll go into lots of other areas. I think that's kind of
That,
where we're seeing that. Is that
Yeah,
right?
absolutely.
totally agree. Yeah, yeah.
Yeah. Go ahead, Sam.
One thing to add to that is humanoids are deployment is just taking off. If you think about the robot market, there's millions and millions already installed. There's a pretty large number of what's called cobots that are coming into the market that are
That's
these
right.
lightweight robots that are assisting humans on the production line, and those are starting to add grippers. It's very very interesting. Again, these production lines are becoming much more flexible. Different products being built, different types of tasks being done, and all of those require grippers. But in addition to that, they need to be able to grip different things. They need to be more successful in gripping things. You cannot drop these things. So it's actually a pretty interesting and growing market in the sense of increasing the accuracy of gripping. It sounds pretty mundane, but it's a hard problem to solve. But it's a very very valuable problem to solve.
Well, it's always the basics, isn't it, to
Yeah,
be addressed
yeah.
to make it really work. Can you be a little bit? Do you want to put a visionary hat? See where we're going in the next 12 to 24 months. What is it still? Still mostly sort of the enterprise, the industrial, or
Yeah.
when do we see the home
Yeah,
robot?
let me give a corollary, right? I mean, I just we talked about a few maybe a decade ago, I'm not sure, but we
Yeah.
talked about level 5 autonomy in cars, and that was a big deal, right? Everybody was saying there's
Yes.
going to be self-driving cars completely everywhere in the market, and maybe even before the decade, right? So that's kind of where all the innovation was going. There was a lot of activity on self-driving cars and so on. There's about a couple of companies right now that are doing self-driving cars and still in a couple of cities in the market. But what took off in the meanwhile were, and most of us probably are driving those cars right now, many of these autonomous functions are used as assists along with what a human is
Yeah.
doing, right? That's
Yeah.
but
Yeah.
that's
Yeah.
deployed today in existing cars, in existing platforms, and so on already. But that's all the innovation, all of the work done for trying to get complete and full level 5 autonomy is what's helping you do the levels 1, 2, 3, 4,
Got it.
and
Got it.
and getting
Yeah.
all the way there. We don't have the
Yeah.
levels yet, or maybe we do, Sam. I'm not sure, but we don't have the levels yet in the market of autonomy of a humanoid and doing all of the functions that's required to do. But you can think about the innovation that's happening is for that holy grail you described. Hey, I'm actually trying to help in the kitchen. I'm trying to fold clothes. I'm trying to help senior citizens, and so on. But there
Hmm.
are, certain sub markets where you'll need a subset of these functions where you don't need
Yeah.
the entire breadth of autonomy, but you'll need a subset of these functions. So how I see it play out is we are in the next 12 to 24 months, we are going to be in this innovation cycle. It's going to be pretty significant from an innovation perspective. We are going to be right smack in the middle of it. And so we're going to be
Yeah.
developing all of these innovations. The deployment of these and the adoption of these is going to iron out over the next 3 to 5 years. And the first deployments will happen. I think it'll be in a variety of markets. I do expect that industrial and cobots and the other kind of markets for synaptics and so on, and for folks in the business of delivering to our shareholders, that market is going to be extremely important for us, as much as the humanoid market as it develops
Yeah.
and the niches develop. But I think that's how I see it. We are in the innovation cycle for the next 24 months. But I think the first solutions will come out on the market over the next year and so on, and then it'll fix itself. But I think the industrial cobot market and so on will be where we see the volumes, and then it'll track behind, right? Tracking right behind it will be the humanoids and all of those things in sub markets.
Got it. Got it.
That's what I see it play out. But I'm more than happy to be corrected and everything happening over the next 2 years.
No, 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 no. I think it's quite interesting because, like you talked about the autonomous lane keep assist, for example, is now not just in the high end, but it's in the mid tier and low end
That's
cars
right.
as a commodity or as a standard feature. So I think what you're saying is we'll see maybe some of these things play out in other areas which we may not even have
The
imagined.
lane keep assist of your robot is going to be moving the touch from your finger to the rest of your palm, to the back of your
Yeah,
palm, to your arm, to your shoulders, to your legs, your torso, your feet. And actually, that's happening. So, more and more areas of your body, of the humanoid's body, are starting to sense. So, that, it doesn't need to be as highly dense, but
yeah.
adding that sense of touch to the rest of the body, that's definitely we see it happening.
All right. I mean, we could talk forever on this, so I'm going to try and draw this to a close. I'm going to ask each of you a question on terms of, through your experience with synaptics and what you've been seeing in sort of enabling this multimodal sensing and robotics. What are the lessons you've learned, and what excites you most? I'm going to start with you, Sam, and then finish with you, Satish.
Sure. Yeah. Lessons for sure is, and this kind of ties in with our culture, right? It's multidisciplinary. It's very, very broad. It's not just the specific silicon that you're dealing with, but it's the firmware, it's the system, it's the algos, understanding the use cases, materials. These are all lessons that we've learned, and we do have that culture of dealing with not just our chip, but the environment outside our chip and learning from our customers. So I think that's going to serve us very, very well going
And
forward.
your excitement,
Yes, very, very
and
excited.
what?
And
Okay, Satish.
Yeah, I mean, listen, the interesting thing in the market, I'll take an interesting take on this one, right? Where people say, hey, when you build something, you do a startup or something like that, try to build a solution that solves a particular problem, right?
Yeah,
Don't build a
yeah,
solution that looks for a problem, right? So that's kind of a typical thing that you want to say. But
exactly.
if you look at what's happening in the market, right? Synaptics, and to some extent, the NVIDIA GPUs and things like that. We built the solution right? If you think about us, we did it for PCs where we understood mechanical design, we understood materials, we understood all of those kinds of things. Solutions built for PCs. And then you take the phone market, we're trying to do a lot of noise avoidance. Hey, when you do this touch, and when you have environmental noise, when you have moisture, when you have temperature, and all of those things, can you reject all of those things and do good capacitive sensing for the phone market, right? Solutions different for a different problem. And now what's happening and what's interesting in the market is all of these solutions that were, pretty basic for different kinds of markets, and you put those all together, and now I'm taking these solutions for a problem that does not exist before, right? Solutions we're looking for, if you think about it, the best problem right now is the humanoid problem, and we build solutions that were for completely different markets, not even involved in that. Nvidia is building their things for, as GPUs for processors, and then going after crypto, and now look at what's happening. Of course, we learned a lot from these things, but sometimes, if only everybody had patience, a problem will arrive, but the solutions that you're building are going to be so coming together in terms of all of the pieces that you put together. So what's exciting for me is, hey, we did a lot of disparate kind of things for different markets and so on, but finally we're getting a platform where pretty much every aspect that we're doing, whether it's the sensing portion, whether it's avoidance of particular solutions, whether it's our processing solution, whether it's our interface solution where we have to show things in displays and all of those things, everything is coming together in a platform where a problem showed up, and we can take our entire company's portfolio, and it's almost like it's shrink wrapped and built for, hey, this problem statement. That's what's most exciting about this whole market for us, and it's exciting me on a day-to-day basis, because now it's like, hey, a problem has arrived where every small thing that we were doing, now the sum can be greater than the parts, which is awesome, which can be really exciting.
Well, I mean, that reminds me of like when I was growing up, I used to watch TV programs, and I'm talking about 70s, where in the presenters would say, "And here's a solution I prepared earlier." It's kind of like you're saying, "Here's what we've got already ready, and it can be applied to this."
Exactly. So it's pretty exciting. So I mean, I'm very excited about the state of where we are, the markets, and the change that we made into edge AI and physical AI. It's a right timing as well. It seems like the right timing, and the traction we are getting is immense. So the validation is really good from the market. The excitement is good from the product perspective, and all our engineers love to be in a cycle of innovation, and so now it puts us back into a high innovation cycle again, which is just kind of the best place to be. So all of those things put together, really excited.
Well, it is the best place to be. Well, Sam Toba and Satish Ganeshan, thank you for coming on this episode of Silicon Grapevine, and look forward to working with you again on something else.
Thank you so much, Nathan. Thanks
Thank
for
you so
having
much.
us.
Yep, thanks for having us.